Hello, everyone. So this is another AIME problem. So we have 2023 AIME 2, question number 3, I guess. Okay. So we have isosceles triangle ABC with angle A is 90. There is a point P inside of the triangle such that three angles are equal to each other and AP is given. So, that's a geometry. There is no figure. So let's get started with drawing that first. Okay. So what I will do, let's actually make a right isosceles triangle. So maybe something like this. Again, it doesn't really matter how you start with, as long as you follow the, I guess, given information so correctly, so we should be fine. So let's take these our legs. And since we are told A is 90, so that has to be A. And there's a point P, PAB. Okay, P, let's call this is B and this is C, PAB. So there will be a point, so PAB, PBC, EBC. Okay, so I feel like let's assume the point is right here. Okay, so it doesn't probably matter. Let's actually try and see. PBC, which will be this guy. PAB will be this guy. PCA, okay, that guy. Okay, so let's actually label those to see how that looks like. So PAB, this is PAB has to be something right there. And then PBC, which will be this guy. And then PCA has to be this guy. Okay, so we do know, angle B is 45, angle C is 45, which is why I'm going to actually start with labeling this like is X and this is X. And if I use the 45, 45, 90 triangle, the hypotenuse will be X root 2, or you can just use a Pythagorean if you don't like it's special right triangle, so that's X root 2. But this angle was 45, this angle is 45, so one part of that 45 is blue angle, so if I call the other part maybe red one, so this guy has to be red as well, because some of these two and then some of these two is 45. So if the one part is the same as the one part of the other 45, so then the second part has to be equal as well to get the same number. Okay, I guess that's obvious. And now we know the red angle and blue angle is 45, but at the same time, this is red, this is blue, right? Which is why I'm gonna call this guy right here. Maybe I should use different color. So the angle right here is 135 degrees. Okay. And also we do have, this triangle, red and blue, which will be the same two angles. So that angle right here is also 135, because this red one plus this blue one is 45, because we know that's the angle B or angle C. So their sum is 45. So this has to be 135. If you add, that's 270. So that means this guy right here is actually 90 degrees, which is really good. Okay, so the triangle APB, let me write here. So APB. Okay, so let me use different color. So the triangle APB is similar. I start with this blue, this similar APB. So this guy, and then the blue angle was right here. So that's B. So I went to P and C. Again, so we have red angle, blue angle, and then 135, 135. They are similar by the angle similarity, okay? So then you can write the ratio easily. So what's the ratio in this triangle? So let's look at, actually, we were given AP as well. So that's 10. So the red angle opposite to 10 in this triangle APB, and the red angle right here is opposite to BP. Okay, equals, in this triangle, maybe I should use X because that's what I'm trying to find. That's opposite 135. And then the same angle is opposite X root 2, which is really nice. X will cancel. That will be equal to 1 over root 2. And that ratio has to be same as this guy. So, but at the same time, maybe I can write the third side. So if I go with the blue angle, which is opposite to BP, so that's equal to BP. And the blue angle on the other triangle is opposite to PC. Okay, so this is good because this is gonna help us. This one, and if I take these two and do cross multiplication, this guy times this guy will be 10 root 2, BP will be 10 root 2. Okay, and then BP is 10 root 2, and then if I take this part now, okay, so if I take this part, so 1 over root 2 equals BP, which is 10 root 2 over PC. So if you do so, that will be like multiply. PC will be 10 root 2 times root 2, which is 20. That's really nice. So that's 10, that's 20. We have 1 to 2 ratio, so this guy has to be 10 root 5. And if you don't see immediately, you know, when you have the legs of a right triangle is 1 to 2 ratio, the hypotenuse will be root 5 times of the smaller one. If you don't know that, so you can just use a Pythagorean to find this guy. And which is why that's also 10 root 5. And then we are gonna almost done with the area. So the area of the triangle ABC, okay, should be 10 root 5 times 10 root 5 over 2. And I can cancel these, that's just 5. So you get root 5 is 5 times 525 times 10 is 250. Okay, so that is my final answer. So there might be some other ways, but I think this is just using basics of similar triangles and just using Pythagorean or special right triangles, okay? So I hope that makes sense, and I'll see you in the next video.